Now let's look at how to predict products. The first one we'll look at is a synthesis reaction. Here you have hydrogen gas and you have oxygen gas, and we know that it's going to make water. How do we know it's going to make water? Well, we know that hydrogen and oxygen are both nonmetals. Therefore, when they combine, you have to consider that oxygen wants to make 2 bonds, hydrogen wants to make 1. So oxygen is going to bond to 2 hydrogens. Okay. Now notice that once we have the equation written out, we've predicted the product, it's not balanced. So you can't go from O2 that contains 2 oxygens to only 1. So keep in mind that you have to then balance the equation. We put a 2 in front of the water, but now we have 4 hydrogens, so we need to put a 2 in front of the hydrogen gas as well. Let's look at a decomposition reaction where you have potassium chlorate. Now, in general, I will actually just write out something like this because it would be rather difficult for you to know that this particular compound dissociates into potassium chloride and oxygen gas. It would be a little bit challenging. Most people would think that it dissociates into their separate ions. So you have a potassium ion, you have the chlorate polyatomic ion, but that's not very stable. Potassium chloride, on the other hand, is extremely stable. Keep in mind, potassium has a +1 charge, chlorine has a -1 charge. And then oxygen gas is also very stable. It's very happy like that. It's a diatomic element. Now again, this is not balanced, so you're going to need to balance it. We have 3 oxygens on this side, 2 oxygens on this side, so we're going to switch those numbers around, put a 3 here and a 2 here. That way we have 6 oxygens on both sides. And since now we have 2 potassiums and 2 chlorines on the reactant side, we also need 2 on the product side. Okay. Again, I know this is going to be a little bit challenging to grasp at first, but we're going to do plenty of practice for you to be able to do these on your own. The next one we'll look at is a single replacement. So now we've got aluminum and iron 2 oxide yields what? So the idea here is now you've got aluminum and you've got iron. Those are 2 metals. And if this is going to be a single replacement, and we know that because aluminum is not bonded to anything, it is on its own, then aluminum would have to take iron's place. Now, we can't just assume that that's always going to happen, because we first need to look at who is tougher, right? Is aluminum reactive enough to take the place of iron? And so the way to determine that is from an activity series. You have this in your reference pages. This is your activity series. And what you need to find is aluminum, which is right here, Al, and iron, Fe, is right here. Now, whichever one is doing the replacing has to be above the other. So since aluminum is above iron on this activity series, that means it is more reactive than iron, meaning it does have the ability to scooch iron out of its place and bond with oxygen rather than leaving iron be. So what's going to happen now is you're going to have aluminum oxide, and remember, aluminum has a +3 charge, oxygen has a -2, so you're going to have aluminum oxide like this, and iron. Okay. Now, again, this is not balanced. You have to make sure that after you predict the products, you need to make sure that the equation is also balanced. So we've got 3 oxygens here. We need 3 here. That gives us 3 irons on this side, so we need 3 irons here. We also have 2 aluminums on this side. That means we need 2 on this side. And now this is a balanced equation. Okay. Let's look at the double replacement example I have. We have aluminum sulfate reacts with calcium hydroxide to yield what? So in this case, you actually don't need to use an activity series. That's only going to be for single replacement reactions. In this case, we're going to go ahead and assume that a displacement does occur. And so what's normally going to happen is aluminum and calcium, those being the two metals here, they're going to want to switch places. Okay, so we're only looking at aluminum, not how many aluminums we have, not just yet. We're only looking at calcium. Okay, so aluminum is now going to bond with this hydroxide. Okay, now aluminum has a +3 charge, hydroxide has a -1. So you're going to need 3 hydroxides to balance out the aluminum. And calcium is going to bond with sulfate. Now, calcium has a +2 charge, sulfate has a -2 charge, so you just need one of each of those ions to balance out the compound. Okay, and I hope you're getting sick of this at this point, because you should know, once again, this is not a balanced equation. We need to make sure that we do balance it. So where should we begin? We've got 2 aluminums on this side, only 1 here, so we can add a 2. Now we have 3 hydroxides on this side, but remember, we now have 2 aluminum hydroxides, so that makes 6 hydroxides here, and we only have 2 here, so we need to add a 3 there. That gives us 3 calciums on the reactant side, only 1 on the product side, so we need to change this 3. And that gives us 3 sulfates on this side, which is balanced out with the reactant side because we do have 3 sulfates there as well. Okay. All right. Now let's take a final peek at a combustion reaction. So our final type of reaction, we're going to look at C3H8. Now some teachers require you to memorize many different names for different hydrocarbons. We're not going to do that. I'll just give them to you. So C3H8 reacts with oxygen. I know that because it's a combustion reaction. And since I know, I can see that, I would give this to you. I would tell you that C3H8 reacts with oxygen or undergoes a combustion reaction. So that should immediately tell you that you make CO2 and H2O. All the time, every time. It's not even predicting products. You are told that you're making carbon dioxide and water. Now after that, you do need to make sure you go ahead and balance out your equation. Okay, the first thing I would do is looking at these carbons. You've got 3 here, 1 on the product side, so I'm going to put a 3 in front. Let's see, you've got 8 hydrogens here, only 2 here, so we're going to put a 4 in front here. And now we're looking at the total number of oxygens. So here you have 6, here you have 4, that equals 10. So we need 5 molecules of oxygen gas to balance out, the oxygen on both sides. Okay. All right, so I realize now that I was a little bit zoomed in, so I'll zoom out in order for you to be able to write down the things that I had written if you choose to do so. Okay. Those are, again, the 5 different types of chemical reactions. We're going to do a good bit of practice determining products or predicting products and then balancing. Again, you should already know how to balance, so at this point the only thing we're adding is identifying the kind of reaction and then predicting those products.